In this video, we're going to review a key feature that is used to describe a function. The key feature we're going to focus in on today is when a function is positive and negative. A function is positive when the graph is above the x-axis. The function is negative when the graph is below the x-axis. So that would be the very first thing you need to do, is identify which part of the graph is above the x-axis, that's positive, and which part of the graph is below the x-axis, which would be negative. After you decide that part, everything is going to focus in around the x-intercept. So if the line is to the right of the x-intercept, that means it's going to be greater than. So it is greater than when the line is to the right of the x-intercept. And that will make more sense once you see an example. It is less than when the line is to the left of the x-intercept. So everything is going to be based off wherever the x-intercept is. Compare that to where the graph is heading. So an example. Here we have a linear function. The first thing we want to do is identify where the x-intercept is. So the x-intercept is right here. And that's going to be at positive 3. So let me erase that. So I'll put that over here. So it's at 3, 0. Okay, now we're going to do the positive parts. So positive, where is it above the x-axis? It's above the x-axis over here. So that's the positive part. So when is that positive? So in relation to positive 3, this blue line is to the left of this point. It's to the left, that means if it's to the left of the point, that means it's less than. So when x is less than 3, this part of the graph is positive. And then this bottom part right here, the bottom part in red, that's the negative part. And it's negative because it's below the x-axis. Now we want to know, when is it below the x-axis? So again, we're going to use our x, and we're going to compare it to our x-intercept of 3. And this is going to the right of our dot. So if it's going to the right of our dot, that means it's going to be greater than that point. Now another thing you can do to help you with that, determine if it's to the left or to the right, is just draw a dashed line through the x-intercept. And then you can determine, is it to the left of the line or to the right of the line? Take a look at our next example. Here's a nonlinear function. Again, we're going to do the same thing. We're going to identify our x-intercept. Here we have two x-intercepts. We have an x-intercept here, and we have an x-intercept here. The one on the right, that one is at 4. And the one on the left here is at 1. So now, I want to identify which part is above the x-axis. So this part right here is above the x-axis. So that one is positive. So now we have to determine when is that positive. So again, everything is based on the x-intercept. It's above the x-axis between these 2 points. So between the 2 x-intercepts, so we could easily write between 1 and 4. And then the negative portion it's below the x-axis, so it's below right here. So in relation to 1, it's to the left of the point, the x-intercept. And if it's to the left of the x-intercept, it's going to be less than 1. So again, if you need to put this dashed line to help you determine if it's to the left or to the right of that point, use that dashed line to determine if it's to the left of the line or to the right of the line. That will make sure that it's in the right direction of the point. We also have another time where it's negative, and that point is in relation to 4. That's over here. So this one we're going to have when x in relation to 4. Again, if I draw a dashed line through the x-intercept, this red line here is to the right of the point, or to the right of our dashed line, which means it's going to be greater than 4. And our last example, another non-linear function. This time we'll start with the negative part. The negative part is down here. This is the part that's below the x-axis. So negative. And in relation to our x-intercept, and the x-intercept is at -4, and it's at +3. So at the -4, you can see that it's below the x-axis between the 2 points. So we could say, I'm going to erase this, the easiest thing would be saying it's negative when it's between their 2 points, which was -4 and 3. And then the positive parts, we have a positive part here, and we have a positive here. Now if I draw my vertical line that goes right through my x-intercept, so it can help us determine is it to the right or to the left of the point. So it's positive when x in relation to -4, the blue line is to the left of the black dashed line, or to the left of -4. So if it's to the left, it's less than -4. And on the other side, if I put the dashed line through the x-intercept, so through 3, so where is x in relation to 3? Well, this blue line is to the right of 3, or to the right of our dashed black line. To the right means it's going to be greater than. So that's how you can determine when a function is positive and when a function is negative.